And we're back on the air on YouTube. Okay, if you go to your Sage worksheet, is everyone logged in? Okay, and open up the worksheet. Go to Share. See where it says Share? On the top? Go to the top. I know. Go to the top. Click on Share. And share with me. Now, my login name for this particular project is LAC 2012, Life After Calculus 2012. So type LAC 2012 right there. That looks kosher. No, it's boom, boom, boom. There you go. All right, so in other words, type that in and click Invite Collaborators. And let's see who shows up. Ooh, let's see. I got Ferguson IV. Okay, I got Graham, I guess. I got Greg, I guess. I got Sarah. I got Lucas. I got Kenny. I got, well, I was there already. I got Jay. Is that everybody who's here today? All right. Huh? Click share. And you got to share with my login name, which is LAC 2012. LAC 2012. It's for, you know, Life After Calculus 2012. 2012. Yell louder, Chris. And then click invite, and it should show up on my screen over there. Or not. Maybe I have to refresh it. Did it come up? Refresh it? Yeah. Yeah, I got to refresh it. Zing. Oh, what problem would that be? Batman? Really? Batman is filled. Now we know the true identity of Batman. All right, what was the problem yesterday? I forget. It's one backslash. One backslash.
You wouldn't sleep. You would just stand next to the window.
No, I just last four.
But it's not. It should be SHS last four, isn't it? SHS backslash, blah, 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 2 letters, right? And then it's SHS 4 numbers. Yay, we're good. Okay. All right, so. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing somebody. I guess we're waiting on you. Oh, God. You forgot your password already?
That's right here.
Uh-huh. Now what's your password? Yeah. This is the perils of making complicated usernames. Did you find it? Okay, click on your worksheet. Luke, what the hell are you? Luke, the Slayer of Demons. Jesus. All right, yeah, now go to the top. Go to share. And then down here, type in my username, which is LAC 2012. And click invite, and I should see your work, okay? And the Luke Slayer, where is it? The second one? Oh, there it is, there, yeah. Alrighty then. Okay. Yes. You have a whole entourage, come on. All right, let's see. What number you got? It used to be first period, right? What number you got? Probably on the bottom. 0129. 0129. 0129. Oh, there it is. Ta-da. Thank you very much. All right, so let's continue our awesomeness here. All right, let me get into my worksheet. All right, so let's take it where we left off. Did we start number 4? We wrote, that's it, right? Okay. Well, number 4 is the sum of 2 angles. Now, remember the sum of 2 angles trig identity? Like the cosine of x plus y? What is it?
X plus y equal, wait, is that like even the sine is a cosine? They have to be complementary
Okay, so how did it go?
I don't know an X and Y more.
Well, let's find out. Let's see. If I want to show the cosine of x plus y, two different angles, I have a problem because it doesn't know that y is a variable. So, if you want to have more than just x acting as a variable, you have to define y as a variable this way. All right, that was not very edifying. I wanted to expand that. Remember we did like the derivative of the cosine? You okay? And then we had to expand it. We wanted, it's sort of like foiling it out. Like when we did the power rule, we had to do x plus 5, x plus h to the 5, and we foiled it out. Well, for cosine of x plus h, didn't we do something like that too? Wasn't it cosine minus sine? I think that's what it was. Let's make it, let's show it. Here we go. Ready? I'm going to show what it is. How do you think I'm going to make it show the right thing? Bool. Not bool. I'm going to make it calculated for me. I'm not going to write out the answer. Dot something. Sim, play, phi, trig. That seemed to work before with trig. There we go. So the cosine of x plus y is the cosine of x times the cosine of y minus the sine of x times the sine of y. I think we wrote it the other way in class. Cosine, cosine minus sine, sine. Cosine of the first times sine of the second minus sine of the first times sine of the second, right? Yes. Likewise, we could do, well, what about this? Let's see. Let me copy this. Put it here. Call it 5. But now what I want to do, I probably don't have to var y again. I'm going to get rid of that. I'm going to do minus. Do you know that one? Cosine, cosine plus sine, sine. Do you remember this stuff from Algebra 2 and Trig? What was it, Honors 3H? It's all built in? Nice, yeah. It's amazing. It calculates this algebraically on the fly. All right, so you have 4 and 5? Okay. So far we know 5 trig identities. And remember, how many did we know before the AP?
Wait, I'm going to change sum of two angles to different two angles.
It's still a sum. How do you subtract? You add the opposite. Thank you. All right. It's still a sum. So now what? How many trig identities did I say you should know cold before the AP? 9. There were 9, and we're going to come up with a new one today, 10. That's only 5. Guess what the next one is? Guess what the next one is?
Sine of x plus y.
Exactly, right. So let's do sine here, sine here, and plus. And we use that also to derive the to find the derivative of the sine. And if I recall correctly, it was cosine, cosine. Wait, sine, cosine. Wait, what is it? Sine, cosine plus sine, cosine, sine. That's what it was. Yeah. Is that what it is? Let's see. Ding. All right. So it's sine of the first times cosine of the second plus cosine of the first times sine of the second is usually how we say it. Okay, but it's there. It's all there. And guess what? Well, that was number 6. Guess what number 7 is?
Subtract sine of x minus
Right.
y.
Do the same thing, but subtracting the 2 angles. And all that does is change the sign in the middle to subtracting. So the sine of x minus y, or the sine of the first angle minus the second angle, sine of the first times cosine of the second minus cosine of the first times sine of the second is usually how you said it in Algebra 2 and Trig, didn't you? Who's stuck? And that's number 7, yeah. We did 6, right? Yeah, okay. All right. So there's 2 more that you knew before the AP. We used all of these, right? The Pythagoreans come up a lot. The sum of 2 angles come a lot. And now the double angles, exactly. Remember the double angles? No, you forgot the double angles? Like, remember, instead of integrating cosine squared, it was easier to integrate 1 plus cosine 2x all over 2. And notice cosine of 2x, you know it. Isn't that cosine of x plus x? So wouldn't that be cosine x squared minus sine x squared? So it has something to do with this, by the way. All right, let's write that down. Let's see. What is the sum, the double angle formula? All right, so let's put in a comment. And let's call it 8. And here's a double angle formula, or identity. So, for example, all right, let's see. How about this? Can I show what the cosine of 2 times x is? Well, sure, but it didn't do anything for me, did it? All right. Then how about if I show it simplified? Simplified trig. Simplify trig. Which is cosine squared minus sine squared, but it replaced sine squared with 1 minus cosine squared. So it's in there. Okay. Now remember what we said, that cosine squared was 1 plus this. So what if I add 1 to that? Let's do a 1 plus that in parentheses, simplify the whole thing. Well, that was silly. Okay. And then, of course, divided by 2. See what I'm doing? I'm sort of deriving that rule. Let's see. So if I take all of this and divide it by 2, don't I get what I want? So look what I did. I did 1 plus cosine 2x all over 2 is cosine squared. All righty. Let's see. Okay, good. All right, but there was another double angle formula. What was the other one? Sine squared equals? Remember sine squared?
Yeah.
Sine squared equals what? 1 minus that. All right, let's see if we can do the same thing and get the sine squared. Do the same idea, except I'm going to do 1 minus that. And this will be the 9th one. And these are all the ones that you knew before the AP. All right, so isn't it true that 1 minus cosine 2x all over 2 is sine squared? There it is. And of course, you can confirm this graphically. If you graph this and you graph this, they'll look the same. And just for fun, why don't we do that? Let's do a plot. How about we plot that? Let's plot this. I'm going to do a plot of that. What'd I do? La la la. I'm missing a parentheses here. Is that sine squared? All I did was I graphed this thingy in here, right here, this thing. I put it in a plot. All right, so I get, is that sine squared? Well, let's see. Let's graph sine squared. I get the same graph, but I only get one graph. Why? Why did I only get one graph? I'm plotting twice. I have to show it, right? Remember, it always shows the last line. But if you want to show stuff before that, you actually have to do the show command. So this should show both plots. And they both should look the same, right? There they are. No problem. You could do the same thing up here. What if I graph this? All right, hang on. Let me come around. Let me graph this. And do a show on that. And graph what it should be, also the cosine squared. And here's 1 plus cosine 2x all over 2, and here's cosine squared. They're the same. All right, anybody stuck? Come around. Bring it where? 8 or 9?
Okay, I had screwed up somewhere very big, and I can't.
8 and 9 are almost the same, except for the 1 plus cosine 2x is number 8.
Yeah, it's on the front.
What does it say? All right, let's see if this is the error. Get that out of there for a minute. No, that's not the error. And let's see if this line has an error. Yeah, it's in here somewhere. What is it? You gotta simplify all of this. You need another parentheses, I think. Right, and then you just copied and pasted that there, so this is probably missing parentheses here too. get rid of that. Nope, something else is going on. Let's see. Well, what's the difference here? All right, how about we get rid of this? Copy this. Do Control C. Control V for paste. Okay, and let's just do it the hard way. Divide by 2 right there. Let's see what you get. Well, no, why not? Oh, because we have to put that in parentheses. All right, so put the whole thing in parentheses, divide all of that by 2. And that's what you wanted, right? So this and this are the same except for the plus. It becomes, all these pluses become minuses. All right, so if this one's got a problem, you can fix it. It's like this, right? All right, who else is stuck? Me. Where? What? What happened?
It's not matching at all.
Ooh, it's not, is it? All right. This is the minus, okay. Think. Sine squared is right. Okay, so this one's off by a factor of... Yeah, you should see 2 plots like that. I'm graphing, right? I'm doing, yeah, okay. What is missing? It's the second one. The second one is right. The first one is wrong. Okay, so plot. That's weird. All right, let's do this. Let's make sure we got everything. Control C. And then, okay, whoops, and try that. No, it's still something screwy. Close. They're not the same. What the heck? 1 minus cosine 2x over 2 and sine squared.
Which is how you wrote it.
Right. Is that exactly what I had? That's the one. That's the same one, right? Okay. This one worked out okay? Well, you didn't graph those? Okay. Well, is this 8 or 9?
I lost track of 8. I thought this was the same one to me.
No, no. All right. 8, 9. Okay. 8.
This is 9.
This is 9. Yeah, so you don't have 8. All right. 8 was this with plus in the middle. And with the plus there, you should get cosine squared.
Right.
That was 8. This is 9, I guess. Right? Yeah. They're the same. So if you get this working, you're fine. It's not graphing the right thing. 1 minus cosine 2x over 2 is sine squared, right? Yes. Are we not dividing everything by 2? All right, get rid of this. Just type it from scratch. Right here. Plot 1, and it's the minus, right? Minus. Oh, I see what it is. You have too many parentheses. This parentheses here will make it the x, the 2 divide only that part. So you need the parentheses in front of the 1. Open there. Oh, wait. We fix one thing at a time. You need open parentheses in front of the 1. Run that. That should be good. All right, now if you do show plot, of that, right, that, yeah. But don't kill it. Control Z, Control C, then go down Control V. Okay, that should do it. Yeah, there it is. Good. Okay. Who else is stuck?
And then the other one was...
The other one's the exact same thing with pluses instead of minuses. You were okay with your graph? Yeah? All the graphs good? Let me know. Who's stuck? Stuck here? Stuck here? You good? Did you have a problem, Greg? Did you say? No? You're good? Okay.
Did I write this wrong?
In number 4? No, this is right. It's just it's giving it to you in tech because your internet connection is too slow. If you save it and quit it and then open it again, it should reevaluate everything properly. Which one was that?
Maybe it's the demons.
Right? This one, right? That's the one, right?
Oh, yeah.
Yeah. So, all right. Who else is stuck? Nobody? All right, so that's the 9 trig identities we've been using all year, right? We need one more to do the next topic. We need one more. Here it is. Are you ready? All righty. And this one's earth-shattering. Here we go. Number 10. No, not. This is Euler's identity. Just when you thought Euler was done doing stuff, he came up with more stuff. No, I mean Euler. You mean Euler, I mean Euler. I say tomato, you say tomato.
Why are we talking about vegetables?
I say potato, you say patata. I say Euler, you say Euler. All right, whatever. All right, okay. How about this?
Biologically fruit, nutritional vegetable.
Taylor. Ready? Hang on to your hats. I want the Taylor expansion of e to the x with respect to x near 0 and give me a 5th degree polynomial.
What the zog is this?
Does this look familiar at all? Do you not know the Maclaurin expansion for e to the x? Is that what that is? Taylor near 0? Okay. By the way, that's not pretty print. I want pretty print. What do I do? Show it. It's the same thing, but show it. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial. This should sound very familiar. No, really? Didn't we ever do the Maclaurin expansion for e to the x?
There's a difference between doing it and learning it.
Well, it's doing it in standard polynomial descending order of degree. Yeah. There might be a way to reverse that, but that's okay. All right, now. But wait. What if I wanted e to the ix? Which I by the way, I mean is the square root of -1, right? Well, now you know how to do it, don't you? Just take every x and do what? If I want e to the ix, not x, just plug in ix, right? Okay.
It doesn't quite give you a series, though.
It doesn't really?
No, it just gives me e raised to the x raised to the I. And that's all it gives me.
Did you write this? I'm raising e to the I and the x. It has to be in parentheses. Did you have it?
Yes.
Hmm.
Oh, now it works.
Interesting.
I had it in parentheses.
You
but
did?
I thought you said x raised to the I. As
No, just ix. All right, now this is very interesting because look at the parts that don't have I. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Does that sound familiar? Look at the parts that have i's in it. X minus x cubed over 3 factorial plus x to the 5 over 5 factorial. Do you know these series? Want to make it more obvious? Okay, fine. Hmm. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial. What function is that? It's, well, if it starts with a 1, it's cosine, right? Now look at the one with the i's. Factor out the i's. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. That's sine, right? Is it? All right, wait, let's make sure. Let's put in, let's do a cosine. Let's just change this to cosine. By the way, there is a Taylor key in HAL, isn't there? Did you find it? All right. All right, isn't that the parts without the i's? Isn't that what this is? The 1 is here, the negative x squared over 2 factorial is here, and the positive x to the 4th over 4 factorial is here, and the negative x to the 6 over 6 factorial is here, and the positive x to the 8th over 8 factorial is there. Now, wait a minute, what about this? What if I put sine? I get the other part, right? X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial, right? Okay. What if I do this? What'd I do? I just multiplied I times that whole thing. I times the sign, yes? Aren't those the exact terms with the i's and everything? Yes? So what did we figure out? That this is this plus this. Isn't that what we just figured out? That e to the ix is cosine of x plus I times sine of x. Isn't that what we just figured out? That's a trig identity that's very important. Hang on. Okay, if you show e to the quantity I times x equals the cosine of x plus I times the sine of x, you see the identity I'm talking about. There it is. Now, what about, by the way, there's a shorthand name for this. This is called cis theta. Cosine plus I sine, CIS, cis theta. That's where the name comes from. Yeah. All right. All right, so by the way, what if we did the bool of this? Notice it's an equals equals. I can do a bool. It's false? What? No way. What are you talking about? Are you smoking something? What? Whoa, I messed up.
Fixed it.
Really? It's true, isn't it? Okay.
Yeah, it's
All right.
true now.
It's true now.
I changed nothing.
I did nothing. All right. This has a lot of applications. Okay? Here's some results of this. Okay? Do you know, let me call this number 10A, the results of 10. The whole rest of my discussion this week and next week is going to be based on this. So let's see if we make sure that we know what we're talking about. Do you know how to raise a real number to a real number?
Yes, you multiply by that method.
Like show, I don't know, 2 plus, well, I'm going to make a point here. 0 times I to the 3 plus 0 times I. Notice these are two real numbers, 2 and 3, but I wrote them in complex form. And you would expect the answer to be what? 8? Amazing. Okay. Do you know how to do a power that's a real, that's an imaginary to a real? Like 0 plus 2i cubed. Do you know how to do that?
Yeah.
Do you know that? How do you do that? 2i times 2i times 2i, right? What's 2i times 2i?
4i squared.
And I squared is, so negative 4 times another 2i.
Make it 8i.
Ah, okay, so we know that. All right, so I know how to raise a real to a real, an imaginary to a real. How about a complex to a real? Notice this has a lot to do with complex numbers. The cis theta stuff, that's a complex number. Cosine plus I sine, that's a real part, that's an imaginary part. Okay. I'm just doing powers. How tough is that? It's not working.
I don't want you to wait, Mr. Garcia.
Alright, no, crap.
You know what? I'm going to pick let me pick an easier example. Let me just do this. I'm going to make an easier example. That's hard to explain. All right, hang on. All right, is that true? How do you know that that's true? How do you usually do 1 plus I cubed?
You multiply 1 plus I.
Times 1 plus I, which is FOIL, right? Then you get another complex number. Times 1 plus I is another FOIL, right?
Yes.
Let's FOIL this out. Let's see. Show the expand of quantity 1 plus I to the 0. Now let's see, how many closes do I need here? Is that right? Did you expect anything to the 0 to be 1? Yes? Okay. What if I do to the first? Did you expect 1 plus I? It writes it the other way. Yeah. What if I do it to the second? Did you expect 2I? I don't know. And the third? What? Do you realize what I'm invoking here? Since 1 plus I cubed is 1 plus I times 1 plus I times 1 plus I, that's FOIL, or the binomial expansion theorem. Do you remember the binomial expansion theorem? Yeah. That's the binomial expansion theorem, yes? So 1 plus I cubed is 1 plus I cubed by the binomial expansion theorem. I got 2, what did I get? Negative 2 plus 2I. Why? Why? Because look what did you get if you plug in I down here. 1 plus 3I plus 3 times what? Which is negative 1 plus I cubed. Now what's I cubed? If I squared is negative 1, negative I. So I have 1 minus 3 is negative 2, and 3I minus I is 2I. That's correct. All right, but that's not new. This is a binomial expansion theorem. It's if I'm taking powers of 1 plus x, right? The answer has powers of 1 and powers of x. X to the 0, x to the 1, x to the 2, x to the 3. 1 to the 0, 1 to the 1, 1 to the 2, 1 to the 3, times the Pascal's triangle numbers, 1, 3, 3, 1. Look, let's make it more obvious. What if I put a 2 here? Then it's powers of 2. See, it's x cubed, x squared, x to the 1, x to the 0, but it's 2 cubed, 2 squared, 2, and, well, it's not obvious because I have another 2 in there. Yeah, that's making it too complicated. Let's not go there right now. Hang on. All right, do you see that 1 plus I cubed is the same thing as 1 plus x cubed if you plug in x as I? All right, so it makes sense that you get negative 2 plus 2I because this is 1 plus 3I minus 3 minus I. All right, that's not new. You knew how to do that. If you have real exponents, you know how to do this. But what if you don't? What if you have an imaginary exponent? How about this? All right, that's 10a and b and c. Sorry, I meant to call this c. All right, here's 10d. What do you get if you do a real to an imaginary? Like 2 plus 0 times I, and just making a point that it's also complex, to the 0 plus 3I. In other words, 2 to the 3I. All right. Okay, now, notice that it is a complex number. Look, what if I numberify this? Doesn't it have a real part and an imaginary part? Isn't it, in fact, a complex number? Okay. So is this the same thing? Let's see, how am I going to write this? How about this? Show e to the log of 2 to the 3i. Is this the same thing? All of this to the 3 times I. Is that the same thing? It is. Why? What is e to the log of 2? By the way, I should clue you in that log in Sage is base e log. This is the natural log. So what's e to the ln of 2 anyway? So this is still 2 to the 3i, right? Okay. But how do you take a power with 1 base and 2 exponents? You multiply the exponents. So this is the same thing. Show, let's see, e to the quantity 3 times log of 2 times I. Isn't that the same thing? Well, wait, that's a problem. How about if I simplify that? Dot simplify. It's weird powers. You know, simplify radical helps with weird powers because it's usually radicals that are a problem. Does that help? No, it doesn't. What happened? What did I do? I did something weird. Let's see. E to the 3 log 2. Oh, I'm not simplifying the whole thing. I'm just simplifying the exponent. Wait, hang on. Ding, put parentheses around the whole thing. It is the same thing, isn't it? Okay. But don't we know what e to the I theta is? What is e to the I theta or e to the ix? What is it? E to the ix is cosine x I sine x, but that's your x. So you see why? Do you see what you're getting? Cosine of 3 log 2 plus I sine of 3 log 2. Same thing. All right, we'll take it from there tomorrow. Yay. All right, don't forget to do save and quit at the top. All right, so this is the same thing as the cosine of 3 log 2 plus I times the sine of 3 log 2. Let's see. Show the cosine of 3 times log of 2 plus I times the sine of 3 times log of 2. Well, let's simplify that. Or how about we make it numerical? Numberify that. And you get the exact same decimals that you had before. All right, so that's how you do complex powers. Interesting. All right, we'll leave it at that. So we did 1 and 2. Yep, I guess I am. All right, did 1 and 2. We're going to do 3 tomorrow. Okay, good. All right, have a nice day, guys. See ya. All righty. Save and quit, yeah, that's it. So everything's there tomorrow if you need it. We're probably going to start a new worksheet tomorrow, but save and quit it so I can see your share. Yay! So 1, 2, 3, 4, 5. Number 10E. Bye-bye. J, Luke, Jared, Phil, Graham, Sarah, Kenny, Kyle, Lucas, Chris, Greg, and Julie. So George and Becker out. Lucas was here. Julie was here. Phil was here. Jared was here. Matt was not. Kyle was. Sarah was. Kenny was not. Dan was. Do I have a Dan? I don't think so. I have a Luke and a Chris and a Greg. I had a Graham, no Kamar, and a J. So I'm missing 1, 2, 3, 4, 5. Out of 17, I should have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's exactly right. Okay. So I go to his thing. I can see it. Oh, I'm still recording. Oh, sorry, YouTube. I'm done. Bye-bye. Bye, YouTube. Where am I? I'll have to restart a new recording then.